Problems on combination of solids. First one, a petrol tank is a cylinder of base diameter 21 centimeters and length 18 centimeters, fitted with conical ends of axis length 9 centimeters. Determine the capacity of the tank. Solution. First get me the figure. So a petrol tank in the form of cylinder, both enclosed with cones, that means conical ends. He asked in capacity means the volume of the total figure, and he given the radius r equals to 21 by 2, because diameter is 21 means radius is half of the diameter, 21 by, and length of the cylinder portion is 18 centimeters and length of the conical portion, coaxial length, is 9 centimeter on, so same conical length of length 9 centimeter means both have same length. Now let diameter of tank D equals to 21 centimeters, then radius of tank R equals to 21 by 2, half of the diameter, 21 by 2 centimeters. Then height of cylindrical portion, height of cylindrical portion h1 equals to 18 centimeters, height of each conical portion h2 equals to 9 centimeters. If you observe here, both have same base, that means radius is common for both cylindrical portion and conical portion, but height may vary. Now capacity means nothing but volume of given solid is nothing but volume of the cylinder portion plus 2 into volume of conical portion, because two cone ends of same dimensions. Now I can take pi r square common, we left with h1 plus 2 by 3 h2, pi 22 by 7 into r square 21 by 2 into 21 by 2, h1 18, 2 by 3 into 9, h2 is 9, 3 ones 3 threes, now we'll get 7 ones 7 threes, 2 ones 2 11s, 11 threes are 33 into 21 by 2, 18 plus 3 2s are 6, that means 33 into 21 by 2 into 24, 2 ones, 2 12s. So on multiplication we get 8316 centimeter cube. This is the capacity of the petrol tank. Go with the second problem. A toy in the form of a toy in the form of a cone of radius 3.5 centimeters mounted on a hemisphere of same radius the total height of the toy is 15.5 centimeters. Find the total surface area of the toy. Solution: a toy in the form of cone surmounted on a hemisphere with radius 3.5 and total height of the toy is 15.5. If you observe that this is also radius and this will be considered a height of the hemisphere, that means same radius. That means for hemisphere the height and radius are same. Now if you want to get the height of the conical portion, 15.5 minus 3.5, that means it is 12 centimeters. Now the slant height L equals to nothing but have to apply the formula of right angle triangle Pythagoras theorem. Now let me write radius of the toy equals to 3.5 centimeters, that is 7/2 centimeters. Total height of the toy equals to 15.5 centimeters. Then height of the conical portion h equals to 15.5 minus 3.5. if you observe that this is the 15.5, if you minus the radius of the hemispherical portion, you will get the height of the conical portion 12 centimeters. Now slant height of the conical portion L equals to square root of 12 square plus 3.5 whole square, that means under root of h square plus r square, that equals to 144 plus 12.25. then L equals to 156.25. then L is nothing but 12.5 centimeters. Now total surface area of the toy is equals to total surface area of the toy is equals to pi RL plus 2 pi r square. If you observe the curved surface area of conical portion plus curved surface area of the hemispherical portion, because both ends are closed and we cannot observe both the ends, so total surface area is nothing but curved surface area of the cone plus curved surface area of the hemisphere. Now take pi r common. You left with L plus 2r pi 22 by 7 into r 7 by 2 from here. L 12.5 plus 2 into r 7 by 2. So 2 get cancelled. Get with 7 cancel. 2 ones, 2 11s. So 11 into 12.5 plus 7, 19. Then you will get 214.5 centimeter square. This is the total surface area of the toy. A rocket is in the form of a circular cylinder closed at the lower end with a cone of the same radius attached to the top. The cylinder is of radius 2.5 meters and height 21 meters, and the cone has slant height, and the cone has slant height 8 meters. Calculate the total surface area and volume of the rocket. Solution: base is circular cylinder and top with cone having same radius. The radius is r equals to 2.5 meters. Then height of the cylindrical portion h1 equals to 21 meters. Slant height of the cone portion L equals to 8 meters. Now we have to find the h value, h2, that means height of the conical portion. Let common base radius r equals to 2.5 meters. Height of cylindrical portion h1 equals to 21 meters. Slant height of conical portion slant height of conical portion L equals to 8 meters. Then height of conical portion H2 equals to under root of L square minus R square. That means 8 square minus R 2.5 whole square. Eight square minus, that means 64 minus 2.5 whole square, 6.25. It means H2 equals to under root of 57.75. That means 7.599. Approximately it is equals to 7.6. Now total surface area of the rocket equals to curved surface area of the cylindrical portion plus curved surface area of the rocket. That means 2 pi RH1 plus pi RL. That means if you take pi out common, 2H1 plus L. That means pi R. If you take pi R common, 22 by 7. R is nothing but 2.5. That means 5 by 2. 2 into H1 means height of the cylindrical portion 21 plus land height 8. So 2 ones, 2 11s. Then you will get 11 5s are 55 by 7 into 42. 21 is 42 plus 8. That means 55 by 7 into 50. That means 55 into 50, that equals to 2750 by 7 divided by 7. Nearly you will get 392.857 centimeter square. Meter square. Now go for the volume of the rocket. Volume of the rocket equals to volume of cylindrical portion plus volume of conical portion. That means pi r square h1 plus 1/3 pi r square h2. That means if you take pi r square common, h1 plus 2h2. So 3.14 into r2, 5 by 2 into 5 by 2 into h1. Height of the cylindrical portion is 21 plus 1/3 h2. H2 is nothing but 7.6. Then 3.14 into 25 by 4 into 21, 7.6 divided by 3 is nothing but plus 2.533. That means 3.14 into 25 by 4 into 23.533. 23.533 into 25 divided by 4 means 3.14 into 147.08 will gives 461.83. so means nearly 461.8 meter cube. This is the volume of the rocket. And for the next problem, a solid is composed of a cylinder with hemispherical ends if the whole length of the solid is 104 centimeters and the radius of each of the hemispherical ends is 7 centimeters. Find the cost of polishing its surface at the rate of rupees 10 per dm square. Solution. So solid is in the shape of the cylinder with hemispherical ends. Length of this total solid is 104 centimeters. Now radius is r, that is 7 centimeters. That means this is 7. Now net length of the cylindrical portion is 104 minus 14. It means 90 centimeters. Solution. Radius of solid, because common radius for both, so r equals to 7 centimeters. Total length of the solid, L equals to 104 centimeters. Then length of cylindrical portion equals to total length 104 minus total length minus 7 and 7, that means 2 into 7, because height of the hemispherical is nothing but radius of the hemispherical. So 104 minus 14, you'll get 90 centimeters. Now total surface area of the solid equals to curved surface area of the cylinder plus 2 into curved surface area of conical portions, because we have two hemispherical portions. So 2 pi r, this is the h, 2 pi r h plus 2 into 2 pi r square. So 2 pi, if I take common, 2 pi r take common, h plus 2r, 2 into r, that means 2 into 22 by 7 into r is 7 into h. What is the h value? 90 plus 2 into r, 2 into 7, 44 into 90 plus 14, then you will get 44 into 104, 44 into 104, that is 4576 centimeter square. But the cost, no, the total cost is given for 1 decimeters. If you want to convert in decimeters, you have to divide them with 100. So convert in decimeter, 45.76 decimeter square. For each decimeter 10 rupees, then total cost for polishing equals to 45.76 into 10, then you will get 457.6 rupees 457.6. End of the session. Problems based on combination of solids, part 3. Question number 1. A right circular cylinder having diameter 12 centimeters and height 15 centimeters is full of ice cream. The ice cream is to be filled. In cones of height 12 centimeters and diameter 6 centimeters, having a hemispherical shape on the top. Find number of cones to be filled. Solution. Now, given diameter d1 equals 12 cm, that means diameter of the cylindrical portion, then radius equals to half of that, r1 equals to 6 centimeters, and the height of the cylindrical portion, that means cylindrical tin, 15 centimeters. Now he given ice cream is in the shape of cone with hemispherical on top, and this radius is r2, which is half of the diameter d2 given for the cone, 6 centimeters. Radius of the cone is 3 centimeters. Then height of the cone is given 12 centimeters. Now n into volume of cone ice cream, nothing but volume of cylinder. So n into volume of the cone, ice cream cone, is not in the shape of ice cream plus hemispherical, that means 1/3 pi r2 square h2 plus plus 2/3 pi r cube, 2/3 pi r cube, 2/3 pi r cube, that equals to volume of the cylinder is nothing but pi r1 square h1. If you take pi common, pi into n into r2 square means nothing but 3 into 3. h2 is nothing but 12, and 1/3 will be here, plus 2/3 means 2 by 3 into r2 cube. That means 3 into 3 into 3, that equals to pi r1 square. That means 6 into h1, 15. So pi get cancelled. Here 3 get cancelled, 3 get cancelled. You're left with n into 36 plus 3 3s are 9, 18. That equals to 6 into 15. Then n equals to 6 into 6 into 15. 36 plus 18 is 54. 6 ones, 6 nines, 3 threes, 3 fives, 3 ones, 3 twos, 5 into 10. Therefore, number of cones n equals to 10. Going for the next problem. A cylindrical tub of radius 5 centimeters and length 9.8 centimeters is full of water. A solid in the form of a right circular cone mounted on a hemisphere is immersed in the tub if the radius of the hemisphere is 3.5 centimeters and height of cone outside the hemisphere is 5 centimeters. Find water left in the tub. Now observe carefully. We have cylindrical tub of radius 5 centimeters and length means height 9.8 centimeters, full of water. That means volume of cylinder is nothing but volume of the water. Now one solid which is in the form of right circular cone of height, conical height 5 centimeters and radius 3.5 centimeters is dropped and immersed in the tub. Then obviously the cylindrical tub is full with water. When you immerse other solid in the tub, the water will spill out. The water spilled out must be equal to the volume of the solid immersed in it. That means total volume of the cylinder minus volume of the solid which is immersed in that gives the water left in the cylindrical tub. Therefore I am finding the first volume of cylindrical tub, that equals to pi r1 square h1. So 22 by 7 into r1 5 into 5 h1 9.8 7.4. So 22 into 25 into 1.4, it gives 250 plus 250 500. 550 into 1.4, that means 55 into 14, so 14 5 700, 14 5 70, 770 centimeter cube. Now volume of solid equals to volume of conical portion by r2 square h1 plus for 2/3 volume of hemispherical portion 2/3 by r2 square, that equals to 1/3 into 22/7 into r square means r2 square means 7/2 whole square to 7/2, h1 means 5 plus 2/3 by 22/7 r2 square 7/2 into 7. If I take common 22/7, 7/2, 7/2, 1/3, that means 22/7 into 7/2 into 7/2 into 1/3, then you're left with 2 pi r cube now. So into 7/2, you're left with here 5 plus 2 into 7/2. 22/7 take 7/2, 7/2 taken common. So 2 into 2 cancel, 7 7 cancel, 2 1s, 2 11s. That means 77/6 into 5 plus 7 12. 6 1s, 6 2s. That means 154 centimeter cube. Therefore water left equals to 770 minus 154, that is 616 centimeter cube. This is the volume of the water left in the tub.